Right, guys, just having a look at the solution to the question on sheet 9. So what does it tell me the question there? No. So we've a cut slope of 1:1.5. So that'll give us a height of 5 meter intervals will give us a 7.5 distance. Fill slope is 1:2, so that'll be 5 to 10, and we've a gradient 1 in 30 rising. So A to B is level at 60 meters. Lines drawn parallel to the road will represent the cut plane as it extends. Lines are drawn at 7.5 millimeter intervals as the contour lines are 5 meters apart and the cut ratio is 1:1.5. Alright? So from A to B, put in your lines 7.5 millimeter intervals. Like so. So that's easy enough, that bit. And make sure you put in them lads swimming up away from the road. So a section at the start of the road must be filled. Lines drawn parallel to the road will represent the fill plane as it extends. So lines drawn at 10 millimeter intervals as the contour lines are 5 meters apart and the fill ratio is 1:2. So because these contours over here are lower, you're going to be filling this up, so that's why you go to this side of it as well. There's that part. So the road rises at a rate of 1 in 30. So there's a contour line coming down here, so that's why they extended it on there. So the road rises at a rate of 1 in 30. We can use this ratio to locate a point at a set altitude on the road. So when we move 150 meters down the road rises 5 meters. So 1 in 30 rising. So then you measure out 1 in 30 from point B and mark it, that's point X. So it's 65 meters high. So B to X rises by 5 meters and the embankment ratio is 1:2. A 5 meter fill cone will have a base radius of 10 because it's 1:2. So 5 meter fill cone, same as this, has a base ratio of 1:2, which is 10. The fill cone is positioned at the high end of the road. So remember, fill high, cut low. So high end of the road, its base will be the same level as the lower end of the road. There's your fill cone. A tangent drawn from B to the base of the cone is on the fill slope plane and has an altitude of 60 meters. Lines drawn parallel to the 60 meter tangent will represent the fill plane as it extends. Lines are drawn at 10 millimeter intervals as the contour lines are 5 meters apart and the fill ratio is 1:2. So the fill decreases in height as it moves away from the road. So 60, 55, 50, 45. Yeah, and see it crosses over this line here. So that's what you heavy in as far as that red dot. Alright. Make sure you include them lads as well. So this was cut away. Jerry, so the hill goes up from the road. This was filled, so the hill goes down away from the road. And then these lads always swim uphill. Right, so the strike is given. So you have the strike. DF was divided into 5 meter intervals to locate a point at an altitude of 65 meters, which is G. So an auxiliary along the strike will locate the dip of the stratum. So extend your strike on. There's your dip. Okay. A vertical borehole at F reveals a vertical depth of the stratum to be 25 meters. Apply this depth to F to locate the footwall and determine the actual thickness of the stratum. So this is important, guys. So make sure you give yourself plenty of space here. So I'd say this person came straight out, got 55 millimeters on their compass, swung an arc. For this one came straight out, got 65 on the compass, swung an arc. And this one come out 85 on the compass, swung an arc. Alright. So apply the depth F to locate the footwall and determine the actual thickness of the stratum. So there's 25 meters. because it was a 25 meter borehole, and then you just draw your line in parallel to your dip line. That gives you your thickness. Alright, just to reiterate on that. Extend your strike on, make sure you put in a dapping line there. Mark off 65 meters, mark off 80 meters, and mark off 55 meters. Draw in your line, there's your dip, make sure you label your dip. Measure back 25 meters because the vertical borehole at F reveals a vertical depth starting to be at 25 meters. Measure back 25, sorry I'm going backwards here, and draw your line in parallel, and that gives you your thickness.